Welcome to the Horsemouth Podcast. My name is Shubhankar Mishra, and this is my excuse to meet fascinating people and learn how they approach work, creativity, and problem solving. My guest today is a PhD student at the University of Oxford at the Department of Theoretical Physics, and she is also at the Mathematical Institute of the university. She is also a member of the MCR at Merton College. She completed her integrated undergrad and master's degree at IIT Kanpur in India, where she majored in material science and engineering with minors in quantum and statistical physics and cognitive science. She's broadly interested in functorial field theories and is supervised by Professor Andre Henriquez at the Mathematical Institute. This afternoon, however, this mathematical prodigy, this category theory expert, is about to discover that there is no morphism between coming for this podcast and sound logic. To check out my guest's work, please visit their website. It's called n-nivedita.com, or you can check out her Instagram. It's very interesting. She uploads a lot of very interesting reels at the intersection of art and mathematics. You can find her at Vij Nivedita. And now, please enjoy my conversation with Nivedita Vij. You were born in the prophetically titled Hoshiarpur in Punjab. So, from there to what is it? The Park Road in Oxford?
That's where my physics department is. Park
Yes.
Road.
These 13th century buildings. So from Hoshiarpur to these buildings, what has that journey been like?
We can spend 2 hours just talking about that. To be honest, I actually miss Hoshiarpur. So I spent the first 16 years of my life in Hoshiarpur in the same little house with my parents, mother and father. And then my father moved with me to Chandigarh for the JEE coaching, which was a big step. First, they tried to send me off by myself, and I was like, oh my God, I can't do this by myself. And my father moved with me, which was a big sacrifice on my parents' part. And because of that, my JEE years were not as traumatic. Like, I can actually look back fondly to them because every weekend, me and my father would go for a local play or do something very nice,
really?
which was just which made my 2 years of JEE prep actually good 2 years of my life instead of terrible 2 years of my life. And then I moved to IIT Kanpur, which was again one of the best 5 years of undergrad experience. And I did my master's because it was the COVID year. I didn't really start off with an integrated degree, but it was a COVID year, so I converted because anyway I would have been home. And then I'm just giving you a brief summary. So then there was the existential crisis of whether to do a corporate job or whether to do some other thing or whether to apply for higher studies. It was a very scary decision making at that point, but I applied to a couple of universities and I got good offers, so I decided that okay, academia it is.
So that was Harvard and Cornell? No.
Harvard, Maryland. There was a Max Planck Institute in Germany, and then Oxford.
Yeah. I've heard about the Planck's constant. It's the same Planck?
It's the same Max Planck. Yeah.
Okay. So, but you were clear that you didn't want to do engineering.
So that's how I started off. So there was actually when I was 16, I did in Hoshiarpur, it was a big deal that I got really good marks in class 10. And it was actually North Zone topper or whatever. So all these newspapers and local people were coming to interview. And now when I read those interviews, I want to hide in a corner and hide my face. But the little me was saying, I want to pursue science. I don't want to do engineering. I want to go to one of the ISCs and I want to do physics. And I'm saying all these things research is hard, but I am prepared. So this was 16-year-old me completely clueless about what life was going to be like. And then somehow it was clear to me that giving J is the rite of passage. Like, even if you want to pursue science, even if you want to do like pure physics, pure maths, you're supposed to like, J is supposed to like prepare you. Like, it's supposed to be like good exercise for your brain. I
But
hope. Uh,
isn't it a little bit? I mean, I am a traumatic outcome of PCM, and so JE was just like I just felt like, wasn't it a little bit of just solving exam papers?
so that is where I was extremely lucky that my teachers were like extremely creative people. So
Hmm.
instead of just like telling us how to like crack it and how to get a really good rank, they would also like encourage us to do Olympiad things, like
Okay.
nice problems. And I would anyway like watch MIT OCW like online lectures on linear algebra, or like it was never, and that's probably why, according to my family, I didn't do like unbelievably good, but it was still like I think it was the best. Like, I really enjoyed that process. And even before like so this is the fun thing that I want to point out, that everybody hates chemistry because they're like, there is absolutely no logic. Like, everything is an exception, and you're given a rule and then there's an exception. And this already started in like class 10th for my ICSE chemistry. Like, people would give us, these are the examples and these are the exceptions,
Yeah.
and no one would tell me why this is an exception. And then I would start bugging my father because I grew up without internet. So I would start asking, like, I can't deal with this. Like, I need to know why something is an exception. And then my father would like talk to his like friends who were professors or something. And then I had these like big books, and I would actually like look up reasons or
Hmm.
ask people about reasons. And everything does have a very logical reason. Like, nothing is arbitrary. And that also made me like enjoy chemistry so much because I would go into the rabbit hole of every exception and find out why it was an exception. It was the coolest explanation ever. So I think for me, Jay was not really like, oh, time yourself and like do these kinds of questions, do that kind of questions. It was really like nice problems which I had fun with and were challenging in ways. So,
Okay. And was Professor Aparna Dar an early influence?
oh, she was my professor at IIT Kanpur.
Okay, so that was later.
Uh, That was later, yeah. She was a major influence
Hmm.
in my choosing mathematics instead of just continuing with engineering.
Why? What did she do?
So I was doing all my materials undergrad courses, and she used to teach this one course called knots, like knot theory, which is like a branch of mathematics. It's topology, and it was supposed to be like an easy, chill course. Everyone did it because they would do well, and it was also very interesting, to be fair. So, like, lots of people from other disciplines would enroll in this course, and I enrolled in this course because I was like, okay, I get to do like a very cool maths course with a very cool person. I did not know her before, but everybody said that she was very nice. And this course sort of changed my perception of mathematics. Like, I realized that I can actually enjoy doing it a lot. Before that, it was, I always thought that this is a challenge that I have to do it to sort of
Hmm.
prove to myself that I can do it. And after that course, I was like, okay, this can also be my happy place. Like, thinking about these things also makes me very happy. So there were like certain kinds of problems, like calculate the homology or something, like black box it completely. And I used to think I can become a professional homology calculator. Like, that's so much fun I like had doing some problems. And also like thinking about her journey from, like, she did her PhD back in the 80s at Stony Brook, and I was like, it was so impressive to me. And she was also just the kindest. Like, she gave me a book at the end of the course with her signature. Like, it was all like a wonderful like experience, and that made me love mathematics. I think that's probably what many people sort of don't get in their life. Like, a teacher who plays the role of making you love the subject. not necessarily like going out of their ways and like trying to sort of convince you that it is the best, but somebody who loves their subject so much that seeing them you realize that okay, this
That
is something
passion
really
is
fun.
infectious.
Very infectious, yeah. That's what
Mhm.
I try to do, but I don't think I'm anywhere close to
Mhm.
like doing that.
So
So yeah,
now that when you are teaching in Oxford
I'm teaching, yeah, yeah.
to the undergrad kids, right? First year,
To
second
the
year.
undergrads, and also like a couple of master's courses sometimes, like not lecturing but tutoring, like doing their problem sets with them
Okay.
and things like
Okay. Okay. That's great. Oh, by the way, speaking of topology, I'm having my afternoon donut.
that.
I,
You're probably the coolest podcaster, so I'm very happy.
Thank you. I practiced this joke before you joined. Okay. But anyway, okay. So let's get down to a little bit about your work and your approach to work.
Yeah.
So I know that perhaps you probably wake up early and go for runs or whatever. Do you?
I that in an ideal universe I would. So
Okay.
let's
You'd
leave
like to
it there.
believe that you do. Okay. So then you get to work, and then what do you exactly do on an average day?
Very, very, very tricky question for a person who's researching in pure maths because it, at least for me, I don't know how other researchers work, but what I feel is like you can sit with a problem and spend a couple of hours on it and still go nowhere. You can try a couple of things, nothing happens. And then you try again and nothing happens. And you try again and nothing happens. And then you try again and you make like infinitesimal progress. Like you see something, like maybe this will work. So it's an extremely non-linear process. You can't be like, oh, I spent 9 to 5 and this is my day and I've done for my day. At least ideally you should be able to, but I personally I struggle with that. So even at night I'm like, oh my god, maybe I should have tried this or maybe I should have tried that. So it's literally just sitting with your iPad or a paper or a notebook or at a board if you're in an office and just like writing your problem and writing all the ingredients you have and then trying to see some structure or trying to do something. I'm emphasizing on trying to do because I cannot say doing something. You're trying to do something. And then on an average day, I might have a meeting with my supervisor for an hour or so where I tell him this is what I'm trying, and if he has some feedback, he would say. Otherwise, both of us are staring at a board filled with cool, I would say cool stuff, but I don't know if others would agree. And that's also a very like surreal experience. Like the world's expert on the field is sitting in the room with you, staring at something and not saying anything, not like just thinking. It's a in At first it took me a while to get used to it because I thought there are always answers. Like there you can refer to a book, you can refer to like a paper from the 80s, or you can like there's always something. And at this stage when there is nothing, when you are like at the edge and there is like beautiful scenery and then I don't know what happens. So that got a bit for me to get used to
Okay,
because
let's
yeah.
break this down. Let's break this down.
Yeah.
Okay, piece by piece. First of all, um, what is the lasting beauty and elegance of chalk on board?
Oh God. So Oxford Maths department had switched to just whiteboards and markers for many years,
That is
and that
so
was
sad.
very sad, very sad. And then now they give options to like professors to change their whiteboard to a blackboard, and my supervisor has two giant blackboards. And I think I don't know what I probably this is a condition thing. Like you've seen people standing at boards and thinking, and then you think, okay, this is nice, but it
Mhm.
actually does have a like a beauty. Like just standing there with someone, like
Mhm.
writing something and thinking. It's I think it's nice, and also like seeing things in front of your eyes. We all have like mental pictures of things. Like
Yeah.
especially all mathematicians have ways of imagining what they are playing with and what they're working with, but just seeing it written in front of you sort of disassociates you from what is happening, and like then your brain can come up with more things and more
Also, I
ideas to
think
approach
category
it.
theory in itself lends itself to being visualized on larger and
Yeah,
larger
like
landscapes, right?
yeah, more lots of diagrams, lots of arrows,
Arrows.
and topology itself, like lots of pictures.
Hmm.
Um, yeah, in general, I am a very geometrically minded person. Like I think in algebra. Like some people think in algebra, but I always think in geometry. So even if I'm working with an algebraic object, like something just purely symbolic,
Hmm.
I would try to have some sort of picture for it for
Okay.
myself, like not
Okay.
completely technical, not completely faithfully honest to the concept, but some picture. That's just how I work.
Okay. So now that we are getting into the realm of abstraction and imagining these worlds and whatever it is, what do you think is the right mindset for a person, for a mathematician, to get into to do rich abstraction?
Oh. Um, I don't think people set out with an aim to do abstraction. I think abstraction falls out of when you deeply understand a concept. Like that's what I believe. That you take any mathematical structure and you work with it for years maybe, and other people work like humanity or mathematicians as like like a group of people work with this idea, and once you truly start to understand it, then you can abstract out its properties. That's usually how it works.
But
So for
isn't it,
example,
isn't it the other
yeah,
way around though?
what do you mean?
Wouldn't you want to abstract to understand?
I think you have to work a lot with the object to be able to abstract the idea. For example, I can tell you like groups or symmetries. Like we have been thinking about symmetries for years. Like we rotate the circle, like symmetries of a circle are like continuous. Like you can rotate the circle by any tiny angle and it remains a circle. Whereas
It's not
triangle, you
chiral,
have
yeah.
like whereas the triangle you have to rotate like three times or like one time with this with the specific angle, so that's discrete, or a square or polygons, like symmetries in general. People were working with symmetries and people started to understand, okay, symmetries form this structure called a group that mathematicians call a group. So there are these operations that you can do, and there is an inverse to this operation. There is the do nothing operation, and so that again, people started developing very rich abstract group theory, but it required people to work, like observe what symmetries are and work with them to abstract out the idea of an abstract group and then develop lots of group theory. So you first like work a lot with primes, you observe primes, you do factorizations and do whatever. Then you abstract it out and then you develop the theory for it. So I think you can't really abstract out before understanding or observing enough instances of something. And then abstraction happens, and that's like sort of like a peak, and then lots of theory building happens. That's
Okay.
how I think of it.
Okay. So then coming back to the question, where do you get what is the mindset that is needed?
Hmm. For like to do the Um, I think just being curious, like just being absolutely, completely fascinated by the structures that you observe.
Mhm.
For the kind of mathematics I do, it's really trying to like describe what physicists do. So physicists have their way of doing things. And for me, like any statement that a physicist makes about things in general, for me, that statement is my motivation. Like I want to turn it into a theorem, or I want to understand it, because the way they say it, mathematicians usually don't understand it well. So for me, that is the motivation. So like being completely fascinated by a statement that you really want to understand it is probably what like is the mindset in general.
Define it, formalize it. try to make sense of it.
For yourself, like not necessarily like the first step is to understand it yourself. Like that should be the starting point.
Okay, so you're saying that the physicist will use the mathematician's help to understand their own thoughts?
No. I think physicists have a certain way of thinking and they have tools that they use and they're absolutely brilliant at. And mathematicians try to give like frameworks. They try to be like, okay, this, what you're trying to say, maybe that fits into this formalism. And then mathematicians go about trying to develop theories about this formalism, and then they can trace back and like come back to physicists and be like, like our theory has this prediction. Like, do you think this makes sense in your physics framework? So there is like they start off, they meet, diverge, come back again, diverge. So it's sort of an exchange like that.
Okay. I think it's I mean, I could be misquoting, but I think it's Eugenia Cheng's quote that she said that it's a lot like translating.
I love her so much. Yes.
Yeah. She's very popular. I mean, in the field of category theory, especially, of course.
Yeah.
Okay, great. So, what is the role of intuition in your job?
I think a lot, but it has to be taken with a pinch of salt. Like you can feel something strongly, like you can feel like this is the way to go, but you can't rely 100% on it. Like it might be or might not be. And the more years you spend, the better you get at like intuitively seeing something is right or wrong, or some idea is good or not. And usually that's what the role of your supervisor is. Like as a PhD student, you'll come up with like 20 different ways of trying to do this, and your supervisor will have some intuition of which might be the best one. And then you try to understand why this person thinks this is the best one, and slowly and gradually you develop your own intuition for how things work. And I think it's all like a matter of like time and like the amount of time you spend with these things, that you develop your own feeling, like that, like understanding of things. So now you can mentally predict maybe this will work and maybe this will not work.
But at the same time, you are, like you said, sitting at a board and just staring at even the world's, best person who's a specialist in this job is looking at something that they perhaps don't know or are trying to push the edge of that circle or that boundary, right?
Yeah.
So in those moments when even your supervisor doesn't know, then nobody knows, right? Effectively.
Nobody knows. Yeah.
So then could your intuition prevail?
Yes. So that is what starts happening towards the end of one's PhD, because then at that time, then we're just like thinking, and yeah, I think it's not like we'll come up with contrasting intuitions, because if you think about it, if there is a structure, then we are both trying to sort of unravel it, and the structure is like too complicated, and then we are like all trying to maybe understand parts of it, or maybe like probe it in some way and things like so then any idea you have is sort of valuable at what you can do to like understand it. So I wouldn't say like mine could prevail or mine would prevail over my supervisors or other people in the room. I think it's a very collective thing. Like even if me and my supervisor are the only people on the planet thinking about it, it's still a collective thing, because you might walk into the corridor and tell some other person like, this is what I'm thinking about. And they might be like, but isn't it something like this in this other field? And then you're like, oh, maybe, like, and then you think. So it's, even if you're like completely by yourself on your problem, it's still like entire humanity's knowledge is sort of pouring into this, like your efforts or your path somehow.
How? I mean, I understood that you're sitting alone by yourself thinking about something, but you are going to take that input of the other person outside, right?
Yeah. So even my point was that at the end of the day, this is something that probably only I care about at this moment.
Right,
Maybe
right.
eventually other mathematicians would, and other physicists would, and other people would who would want to read this. But in that moment, I might feel like I am the only person who cares about it, and I'm the only person who like feels the need to do this thing. But I am not alone in the sense that like everything that has been done before in this past sort of pours into it. And
Okay, like
every
that.
person I try to engage with will like have an input
Right,
that will contribute to it.
right,
So
right.
even if you are by yourself solving something, you're not really by yourself because there's like
You have
so
support.
much being poured into, yeah.
Hmm. Okay.
Or you seek support, or like even if there's like invisible support, like just somebody sort of giving you their lunch break while eating a sandwich while you're telling them this is what you're trying to do is like is support
Just
in some
listening to
way.
you.
Yeah.
Oh. Mhm. This other thing that I was thinking about was that when you are in that, I don't know, the third world, what do you call it, when you are abstracting and you're thinking about some,
Yeah.
you're getting into this universe of infinities, and in whatever it is, though, that fascinating
Yeah.
world that you spend a majority of your time in. When you're working with somebody, I mean, this is just, I mean, I'm just revealing to you how dumb I am, but isn't it a little bit like dreaming and showing somebody else, like trying to have a co-dream with somebody? Isn't it a little bit like that?
I think so. Yeah, like not a core dream, but it's really like I sometimes imagine it like holding somebody's hand and like pulling them and be like, ah, like look how beautiful this is, and look how beautiful this is, and this has to make sense. Like, don't you agree? This has to work out. And it is like taking somebody else for a walk in your world, but I don't think like mathematicians usually think of it like this. But I think I still have like that child's perspective of this world, and I still think that when I'm like telling somebody about my work, I'm actually like taking them
Yeah.
into this like in realm.
Like
But
it's
yeah.
like reading the same book, but you'd imagine the characters differently, right? Like you'll
Yeah.
probably, unless they're described a certain way. So
Yeah,
is
even then, like mathematics is so crisp and there are definitions, but the way you sort of perceive it, the way you understand it, it's so unique to everybody. Like the way
Mhm,
people think about it, it's
mhm.
yeah.
Okay. So we'll come back to this world later on. Just I need your little help, as I think I've revealed to you during just the course of the last 15-20 minutes, that I can't grasp concepts very quickly. I'm rather dumb that way. So what's the secret of grasping concepts really quickly? Because I know that you've had to do that.
Okay, so the first key thing is do not think of yourself as that. I think I personally have experienced, and almost every other PhD student, every other professor has experienced some sort of like imposter syndrome. Like everybody feels like I don't belong. Like when I'm standing at a board with my supervisor sitting in the background, I feel like this enormous pressure sometimes to be able to do this, like to be able to like say something intelligent. And it doesn't always happen. And you have to be like okay with it and at peace with it, and just let yourself be. So the first thing is that you're not dumb. And I am of the opinion that any human can grasp any concept given, like, if it is introduced in the right way, like if it is introduced in a way that would interest them, if it is introduced in a way that they would want to engage with it. Like you can't force feed somebody some concept, but given that somebody is actually curious, I think there is always like, no matter how abstract an idea, you can always communicate bits and pieces of it, like paint some picture that this person would be happy to take home. I believe that.
Yeah,
So
but you're
then
talking
you,
about the teacher's job.
yeah, no,
I'm
so we are all teaching ourselves, right?
okay.
Like when I'm reading a paper, even when I was like in school, even if I was reading geography books or anything, like I somehow always think of it as like teaching myself something. So if I'm reading something, I don't understand it, I'll stare at the definition, I'll take a paper and try to like break it down completely. But what is key is you have to take that thing that you said quickly out of the picture completely. Like learning will not happen if somebody's running behind you with a yardstick saying, this, like, you've spent 2 hours on it and now, like, you're stupid because you don't understand it. Like, that is why most of people's, like, JE experience is bad, because there is, like, this clock sitting and there is this yardstick. So I don't want to, like, paint a picture that clock is never there and that yardstick is never there. But I think true learning happens when you are able to like let those things go. And like suppose somebody introduces something to you, like, or we read something in a book, there is a high chance that you will not understand it in the first place. Very high chance. And then starts the journey of telling yourself that it's absolutely okay, I don't understand it. Then you try to like break it down, look up the internet, look up other books. Like, so grasping a concept only requires curiosity and that feeling of not giving up. Like that confidence that I can understand it. Like in principle, I can. In theory, I can. And that is all that like drives me. Like I tell myself, like no matter, so I go to like lectures or seminars of things that I don't like understand or engage with, and I tell myself, so the starting point is, in principle, I can understand it. And you, then you feel slightly more at home, and then your brain is more open to learning. So I think that is sort of the idea. Like, I am very confident that I can take the most abstract thing that I work with and try to tell you it like in a way that you will be happy and you will appreciate the idea.
Yeah.
And usually, like, this is me, a human, telling you, but usually we'll read a paper or read a book, and that becomes harder because there is nobody telling you how like they feel about it, and these are just words on a paper. But then you can sort of like try to play both the roles and somehow meet in between. So that's how I think about it.
Was your inner voice always kind to yourself?
um no. Uh, no. It is kind, it's very kind and very supportive at times, but I am actually training. Like, that is one thing that is a part of me mentally training myself to be kind to myself. Because somehow I don't want to say like it's a problem of growing up in India, or it's a problem of like just somehow our system of validation like is completely broken. Like from very early on you want your name on that chart on your class with a little star on it, and from very early on you want like the parent teacher meeting to be your teacher saying good things to your parents, or your parents saying good things to your teachers. And I have like really bad memories of me being like a tiny person, and the teachers would always say something positive, and then my parents would say something like, oh, she doesn't eat, or something like completely out of context, and I would like just start crying because like that feedback, we are just not taught to like engage with it. And similarly, even now I find myself like looking for my supervisor's validation sometimes. Like if I've done something, I want him to be like, this is good, this is great. But that is not how we should be operating. Like we should be the ones who should be validating our work, our efforts. And somehow in our society that's slightly like we are not taught early on how to do that. So my inner voice is usually not kind. Like I always like sometimes I think, oh my God, I'm so stupid. Like I should not be doing maths. Like I should have done something else. I should have stuck to engineering, or I should have
That
gotten a
happens
job.
today?
Sometimes even today. So that's why I'm saying like I'm trying to train myself to not feel that, because it takes a lot to like be okay being in a room and not comparing yourself to everybody else and sort of like putting yourself somewhere. So I think that is something that takes a lot of learning. So I'm now trying very hard for my inner voice to be as kind to me as possible and as supportive, and like just enjoying the process and enjoying learning and enjoying like life in general as a mathematician. I don't know if I will be a mathematician for the rest of my life, but right now I want to feel like I belong and I love doing what I'm doing. And it takes work, like it really takes work because we do not feel like the self validation is a very tricky like thing to have in yourself. So yeah.
Tricky in the sense that if there is too much of it, you could get high-headed.
Uh, uh, I I personally don't think I have that like inclination
That won't happen.
because but not high-headed, that you think that somebody would be really proud of what they're doing. But I still think that is still much better than like always feeling underconfident. But if you are feeling proud of what you have done, like feel proud, then it's up to other people to like sort of take it with a pinch of salt and like understand that okay, this is something you're proud of, cool. Then like it's other people who will take your high-headedness or pride in whatever way they want to. But I don't want to comment on like whether being proud of something is a good thing or a bad thing, but I think like not being too self-critical is very important.
Okay. Okay, so two curiosities here. One, say you have a bad day today. You're staring at the board and nothing comes to you. I don't know if you qualify that as a bad day. It could be a very productive day in your head, but say it's a bad day.
Yeah.
That stress and that overwhelming feeling or whatever that is, the negative feeling, how the hell does it translate into like social media, like posts and creativity, and what is that transaction?
Oh gosh. Okay. I had not expected you would ask me this.
If you're not comfortable answering, I mean,
No,
let me
no,
know.
no. I'm very happy to actually.
Okay.
This is also like I am thinking of this as like also me walking, taking a walk in my own head, which is always a nice feeling. Like I really
Wow.
appreciate it. So, like okay, bad. I can give you a more like a better example of a bad day. Suppose I thought I had proved something, and I take it to my supervisor, and I'm like I think this is done, and then he's like he looks at it and then he's like, no, that little thing doesn't work. Okay, that is a bad day because you thought something is done and something is not done, so you're back to square zero trying to do something. So those are bad days. But and I think there are some things that I try to then like keep me grounded. So of course then you start spiraling. Then you're like, I will not finish my PhD. I will not get a job. Like, this doesn't work. What will happen? Then there is like the entire, like,
Crashing down.
big dark, like, yeah, then you have this tendency to crash. And in those moments, I try to tell myself that I am living in a place that is absolutely stunning. I have a life that I need to be grateful for. I have a supervisor who's kind. Like, he is not telling me that he would kick me out if I don't do this. No one's telling me to publish before you graduate. There is like very little pressure, and that pressure is self-induced. So I then try to calm myself. I'm like, this isn't this is a difficult problem. Like, this is no one in the world knows the answer to this. I am trying very hard to answer it. And okay, this is back at square zero, don't know the answer. Okay, breathe. Then I sometimes like posting on social media about like really abstract maths concepts which most people don't understand. It's like somebody recently like uh, texted me in saying that it feels like you're like looking at grandmasters playing chess. You don't really understand what they're doing, but like you still gain something, some tiny thing
Absolutely.
out of
Yeah,
it.
absolutely.
So I was like, okay, that's how I do feel like when I watch chess. So that's what people are feeling when I say
Exactly.
these like
Yeah, yeah.
abstract things. So I think that makes, and then like engaging with people who are trying to understand what I say is really fun. And me just also like telling myself that I absolutely love these things is like it's again sort of there is like a tiny link broken in sort of some validation that I'm not really like looking at the mirror and telling myself I love these things, but actually putting it on the internet. But I think that I can like
Yeah,
cut myself some slack on.
yeah.
But then I also like go to the gym, for example, or like go to a concert, like disassociate yourself from that feeling that you failed and
Hmm.
then come back to it. Like, okay, then life happens. Time is going to heal. Like, next 1 week you might feel like, oh my God, I can't see my supervisor. Like, how could I have made such a stupid mistake? But then life goes on. Like in a week you will come up with a nicer idea. In a week your supervisor will not even like remember that this was what felt. And also you always learn when you make a mistake. You're like, okay, this was something that I thought was true. It is not true. And you learned something out of it. It's like in theory, these are like the little flags that you can like tell yourself you have to keep like little checkposts,
Yeah.
but in practice sometimes
It gets muddy. Yeah.
yeah.
I'm just curious, and I mean, we can cut this out if you're not comfortable answering this question, but
No.
the relationship between, say, a PhD student and their supervisor, from whatever you're describing, it sounds a little bit of like, it's a lot of your validation, a lot of your learning is in the hands of one human. It's one person doing, looking, and, their validation could obviously mean everything to you. I'm sure you're blessed with an amazing supervisor. So could you tell me what kind of a relationship that is and how that informs your learning?
So there are two, like, of course it is. So this will actually vary from person to person, like
Exactly.
how their group, like how their field behaves. Like there are people who are experimentalists and they're in the lab and they only see their supervisor once a week or like even less, and just to update that this is what is happening. And some people, like supervisors, are usually very busy traveling, teaching. Like you can't rely on this person. But I think it's still very important that this person is kind and supportive. I think those are the, like, when you are applying for PhD positions, you are basically looking at somebody's work and you can be like extremely impressed by their papers. And but I think that is like, it's slightly scary. So I personally feel like you should have some sort of interaction, like some sort of like a online video call, like interacting. And I, before my PhDs, actually did have these, like, I would write to people saying I'm interested in working with you. Could we like meet for a
Hmm.
25-minute or a 30-minute chat? And there you try to like gauge whether you will be like compatible working with this person. And I think most of the people in academia, like touchwood, are very kind, very nice. And I like this. I don't want to say that their validation matters a lot, but I think their like invisible support matters a lot. So like your and like fear of failing is like sort of, you can deal with it better if you know that your supervisor is supportive and your supervisor is kind, because then like when I was saying like you can get rid of that clock and you can get rid of that yardstick, it's similarly you can get rid of that fear of failing if you know that somebody is kind. And I think it's, you are not your supervisor's responsibility, your supervisor is not accountable, but it's just like this support. Like you can actually be stuck at a problem and email this person at 4 a.m. saying, I tried this doesn't work. And can we talk about it at some point? Because who else in the universe
Will
can you
understand.
like,
Yeah.
yeah, exactly. So I think that support, whether direct or indirect or invisible, like that is very, very important.
Hmm. Okay. So, I know you described yourself as somebody who has mood swings. I mean, it's there in your bio. So when you have a mood swing, because you're talking about removing that clock from your mind, which means you're kind
Yeah.
of inducing a state of play, a state of almost wanting to have fun with whatever it is you're doing and doing it in a relaxed way. So when your mood is off, for whatever reason it is, you're off that day, um, how do you stop that from affecting whatever it is your pursuit is?
Okay, so I'm very grateful to you that you asked me this. Extremely grateful. You have no idea. So, uh, like, social media is giving us so much awareness these days, which when I was growing up, I did not have. I have now I was diagnosed by my GP or my doctor in Oxford by this condition called PMDD. So it's like a premenstrual dysphoric disorder, and it's not something scary. It's basically like your body reacts more to hormonal changes. So it's not like your hormones are out of order, but your body just has more receptors to it. So your brain will have more receptors to it, your gut will have more receptors to it, your skin will have more receptors for it. And you can imagine, like, hormones are just traveling around in your bloodstream, and wherever there is a receptor, they will interact and cause whatever they are like evolved to do with that. So, when I was 16, I remember like feeling overwhelmed for no reason or feeling sad for no reason. And I had no idea why this was happening. And that's also like one of the critical points that I called my father when I was by myself, like preparing for JE. And I was like, I can't do this by myself because I was very young and I was very new to these feelings of like feeling low or like feeling just completely overwhelmed and not being able to process, not being able to do anything. And that's like uh when my father like came, and then I told you like we would go for a walk, we would go to plays, like we would do other things. And that sort of it's we still didn't know what was causing it. Like this thing, it came and went. I would cry sometimes, and I thought I'm crying because I didn't get like top whatever 10 rank in my coaching or whatever. But it had absolutely nothing to do with the external factors. It was completely internal. It was some completely anatomical, biological, and we did not know. And when I went to IIT, again, there were like days that I would feel low. There were days that I would be happy and like working. And it was always like a roller coaster where at any random day, it would completely be up to the universe how productive I would be, how creative I would be, how motivated I would be, or how low or how sad, how completely ready to let go of everything. So it was always like I never understood. But then a mathematician's brain or a human's brain, like there's nothing to do with mathematics, we try to see patterns. So I was like, okay, this has been happening to me for the last 7 years or whatever. What is it? Like, why do I sometimes feel like I'm in such intense mental pain that I need to go see like my local Kanpur doctor and tell them that I'm in pain and not be able to describe that pain? Like, it's not a headache, it's not a backache, but there's some pain. And I was like, okay, this happens. Let's start collecting data. So then after like years and years of data collection about how motivated I feel, how low I feel, how how fit I feel physically, like after all of that, I was like, this is periodic. So one would think this is so stupid. Like it took me years to understand that like my hormones affect my like motivation to do things, but it's something so biological. Like these days we see these like fitness people telling that like female people, like people who are on female hormones, need to train in a very specific way. So there are days when I actually go and run like a half marathon. Like I once went out for a run and I completed like 22.5, and there are days when I can't even like go down the stairs and come up the stairs because you are so motivated. And this is just physical changes, and for me this also translates to my like creativity and my love for mathematics. So I can feel extremely motivated one day when I want to work, and in the low little phase of this cycle, I can feel very low and I can feel that I'm not good enough and I can feel I'm
Mm.
not creative. But the good thing is that I told my supervisor this happens, like I told people around myself this happens, and everyone is so supportive because it's not like I'm trying to like ask them to like cut me a slack
Yeah.
and give me a leave. It's really just to be kind. So if I turn, like if there is a 9 a.m. meeting on a Friday, very close to when I am feeling low, I can email my professor saying I am trying very hard to make it to the meeting, but I can't bring myself to. Can we instead meet online? So even if I'm in Oxford and from my room, I can ask him to meet me online where I can
Yeah.
tell him this is what I'm trying. Or at other times, I can be like, can we I've actually had times where I've went for this meeting and I've told him, can we just discuss this other, like, completely different mathematic, like, idea instead of our usual work? Because that will help me not feel bad
Mm.
about the progress of this or whatever. And then we discuss something completely different, which is that like makes me realize, okay, I actually just love thinking about these things. So it's actually like being in a supportive environment. So my mood swings do affect my creativity, my like day-to-day
Everything.
productivity, everything. And I think it's very important that we are okay with it. Like not just that, like social interactions, whether I can go to like a 4 p.m. coffee and cake thing in the maths department, or whether I don't feel like I can go. Like everything gets
Mm.
affected. But as long as you are aware of that, and as long as people, your closest friends, your supervisor, like whoever your nearest neighbors are in this social context, as
Mm.
long as they're aware that this is something you struggle with and this is not something to judge you for and this is not something that that they should be very worried about, I think then you like feel safe and then you can try to slowly like step out and be like, even if you're not feeling your best, you can still like go for this like social thing.
Whatever
So
it is, yeah, you can push
yeah,
yourself.
whatever it is. Yeah, but this was very new to me that, okay, my motivation to do things also suffers because when you are in the exam context or like still IIT or JEE, you have like some sort of like you can still bring yourself to do it. Like you can still bring yourself to learn for it because there is like this finite corpus. Like you know that this is what you have to learn for the course.
Yeah.
Whereas when you are a researcher, it is really not a finite thing. Like there is really no boundary. Like
Yeah.
you can't tell yourself that okay, this is what I need to learn because you're not really like learning
Inspiration could come from
anymore.
anywhere. Yeah.
Yeah, and you're not really and inspiration or like there is no like target, like there is nothing like, oh, if I do this then I can relax because
Mm.
there is really like as much work as you want to do. So
Yeah.
that can be very overwhelming because I'm like, okay, even if I do this, there are all these things that I need to do, like all these theorems that I need to prove, or all this work that should be in my PhD ideally. So that, like, trying to overcome that feeling of being overwhelmed again takes a lot of effort.
Energy.
I would say. Yeah.
Yeah.
Not not energy, but just conscious effort. Like
Hmm.
it's not something that is draining, but it does require you to like consciously, mindfully tell yourself that, okay, right now I'm feeling overwhelmed by this large, like I don't know, universe of things. I'm going to place myself and just look locally. Like
Hmm.
locally, maybe if I respond to this email, maybe if I try to like mark this work for my tutorial, and maybe if I plan this thing ahead, like locally, then you try to give yourself little sort of more planned day instead of like being overwhelmed by how
Hmm.
there's nothing you can do.
So, are you planning when you are hiking in the Alps or when you're running around Oxford? Are you
Yeah.
planning in your head? Are you listening to music?
Um, it really like depends. So there have been some hikes. Like I'm very lucky, like in the field that I am, I get to travel to very nice places with very
Yes.
nice mathematicians.
Yes.
So there have been hikes where you're actually like talking about maths. Or like one of my favorite memory is that my supervisor and I, we usually like travel by train whenever we have to go anywhere in Europe. So even if it is like a 14-hour train journey. In
Okay.
India, it's not uncommon.
Yeah,
In
yeah,
Europe, it's very uncommon because it's much more expensive to take trains than to
yeah.
take cheap flights. But we try to take trains whenever we can. So once we were coming from Hamburg, and we were like sitting in a train with like 9 sheets of paper in front of us, like 9 A4s trying to do something. And it
Wow.
was just so surreal. But when I'm like running, I try to do these things to actually not like spiral. So
Hmm.
maybe for a bit of whatever activity I'm doing, I'll still be like, okay, after this I will do this, and after this I'll do that. So there is some planning,
Yeah.
but mostly I want to disassociate. So
Okay.
mostly it's like listen to like good music and paint or run or like do something that like tells you that, okay, mathematics is something you absolutely love, but it is not like the oxygen you're breathing. It is something that is out
Hmm.
there and you love doing it, but it is not like critical to your survival
Yeah.
somehow.
Yeah.
And you are much more than that. And
Hmm.
you're so I think like these kind of little monologues happen throughout, but
You're
and
talking to
they're more
yourself.
or yeah, they're more or less subconscious and automated somehow.
Hmm. Hmm. Okay. So now let's do a little memory exercise. Say you're in Paris, and you visit, what is that, Museum Les Orangeries? I'm butchering the
Yeah.
pronunciation.
Yeah.
And you're standing in front of a huge Monet canvas.
Oh.
Either it could be water lilies or whatever it is. When you're looking at the painting, are you marveling at how, amazing the brushwork is, how beautiful the color contrast is, what impressionistic style he's invented? Or are you thinking, oh my god, this pond is a quantum field and these ripples are excitations? And is that like the thought process? Like, is that where you're going? How do you perceive art in your life?
Um, hmm. So instead of Monet, I will try to talk about Van Gogh
Okay,
because I
great.
only saw like 2 or 3 Monets,
Hmm.
which I en engaged with, but I saw a lot of Van Goghs that
Hmm.
actually like
I'll tell you
I
my favorite go is of course we'll talk about that later also, but there's this painting called Starry Night over Rhone. I don't know if you've seen
mm-hmm.
that.
Yeah,
So
I have seen it.
it's not Starry Night, it's Starry Night over
Yeah, yeah.
Rhone.
Totally.
So that's
That is
a big.
actually the one I saw. So,
Oh,
um,
beautiful. Okay.
uh, but for me, I think I've recently realized, well, not recently, even when I was in my undergrad, there is this like philosophy of psychology which is called Gestalt, which says that the sum is larger, like the whole is bigger than the sum of its parts.
Paths.
So this is like a Gestalt philosophy kind of thing. And this is something that I also like observe a lot in mathematics and in geometry. Like you can have a very non-trivial global. So this is a very common thing in mathematics or the kind of geometry that I do, that globally you can have something extremely non-trivial. Like there can be twists and there can be like complicated things, but locally, like around every point, everything is nice and
Smooth.
like understandable and like trivial, and we say trivial like locally trivial. So and when I look at art, I okay, for the first thing is that you get an impression of like what this global thing is, but for me I actually found myself like admiring each stroke in a Van Gogh. And it's unbelievable. Like they're all of different colors and they're some are thick, some are thin, and some are like really like there's little like blobs of paint. And and then I can actually get lost in it locally without like thinking much about like the giant big masterpiece that this entire thing is. So for me, I also appreciate like every tiny square pixel of it. and then you sort of step back, and then you have like this rush of emotions of what it is
Hmm.
globally. So I don't think I am the person who like tries to look for mathematical structures in art. There are a lot of people who find things more appealing, more beautiful if it's more symmetric, if it's more like that's all inbuilt in our heads. But for me, I think art is more like just like appreciating what your human brain can do. Like just like
Hmm.
just like we are talking, just like somebody writes. It's the same feeling that somebody's like painted something, and to like be able to go very close to what would have happened in their mind when they were doing it. That's how I
Their
usually,
visions.
yeah.
Okay. So, in preparation for this podcast, and trust me, it was preparation. I was watching Oppenheimer. So
Ah,
there's this shot very in the early in the film where Oppenheimer is looking what I think he's looking at a Picasso. There's an abstract painting of Picasso, and
mhm.
he's looking at it, and I guess at the same time he's thinking about string theory or whatever it is. Those loops are forming in his head if you've seen the film. So. Um, are you also troubled by visions of a hidden universe?
Uh, I don't think I'm like not a hidden universe, but I'm troubled by like wanting to understand ours. Or so I wouldn't say I'm like it's not. Sometimes I do dream about maths, but I don't think those are like troubling dreams. Like I don't think for me at this stage still it is slight anguish, but much more excitement. And I don't ever want this balance to go off. Like, I don't want it to be a lot more anguish and very little excitement. And
Yeah.
I think you always want to still be excited.
Hmm.
And you will obviously have this little anguish. Like, because when you don't understand something, you feel like something is off. And I wish I could get it.
Yeah.
Uh, but I don't think I would say I'm troubled by it. I think I'm very grateful for it. If at
Hmm.
all I have it,
Hmm.
I am very grateful. So I wouldn't say I'm troubled by it. But I actually like for people who want to watch like films. Well, there are lots of nice films, but one of the very insane ones is this thing called Proof. Like it's a movie called Proof. It was also
Okay.
a play, I think, which is
Okay.
about this mathematician who is very old and I think demented by the towards the end of his life.
Okay.
And he thinks that he has like done this like grand proof.
Hmm.
And he's like trying so hard, like papers and papers are around him, like books,
Hmm.
piles of notebooks. And then he tells his daughter, who's also a mathematician, that he has done this proof, and he's like standing in the snow, and he's like, I'll tell you how I did it. And then he starts reading absolute gibberish
Oh my God.
out of his notebook. So that
Hmm.
was like goosebumps.
Yeah. Yeah. A
And
little like The
I
Shining.
am,
Yeah.
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 So I think like there is always a risk that you will stop making sense.
Hmm.
And that's why it's very important to be grounded. So of course it's important to be passionate about what you're doing, but it also is very important to be grounded and to know that you are just trying to like discover some structures. You're trying to do something. And right now we are all sane and we are happy, but who knows when the brain equilibrium is going to go
Yeah.
off, right? So it's very important to be like mindful of that you're doing something which you love doing, but it is not a dictator of your life,
Hmm.
right? And I'm so lucky. Like there is Professor Graham Segal here, who's like whose name is probably going to appear in the title of my PhD thesis and also in like
2D
another
chiral
paper.
conformal field theories.
Yeah,
Yeah.
like he was the person who actually came up with this idea
Oh.
in 1988 that
Okay.
like that you can that quantum field theory, like physicists were doing it, Feynman was doing all these path integral things, and mathematicians had no clue. what are these people trying to do, because what they were saying did not mean much to mathematicians. And then like Professor Graham, he sort of again abstracted out the idea. He was like, okay, I don't understand what a path integral is trying to do. This is an infinite thing. Physicists have some way of making sense of it, playing with it. As a mathematician, this is completely like complete like a painting to me. Like it doesn't mean mathematically anything to me.
Okay.
And so after like talking to a lot of physicists and like having done work in mathematics and mathematical physics, he sort of abstracted out the idea. Like he was like, okay, I'm going to try to write some axioms which capture what the path integral is trying to do. So he does like and this abstraction doesn't help you solve the path integral. Like it doesn't give you any answers. It doesn't give you any numbers at the end, which physicists have been trying to do to get numbers to nearer, like better and better approximations. So this is just abstracted out what it is trying to do. And now like there are like 20, 30 years of work just like taking this formalism and just like playing with it. So just like physicists play with their path integral and try to do computations, mathematicians have this axiomatic framework that they can try to prove things about and then go back. And I'm so lucky that like he's still around sometimes, and I meet with him and I chat with him. And it's such a surreal experience. Like I cannot be more grateful to be like talking to somebody who's actually like sort of
Dedicated their
invented the
lives.
field. Yeah. And then like listening to how he thinks about it. And we of course have contentions because there have been 30 years where I like to think of it in a more modern way and he likes to think of it like in a more traditional way. And then I'm like, I will end up convincing you. And he's like, no. So it's like it's a great thing. And you also have to be okay with like that you will meet people who will think what you're trying to do is not useful. Like if I talk to a physicist, they'll be like, what new are you going to give us? Like this is the thing that is thrown at category theorists or people who try to do like these abstract things a lot. Like what new can you prove with it? And sometimes it's not about proving something new. Sometimes it's just about understanding like the things that are already present and present them in a language that will then tell us something new. Maybe 20 years later, maybe never. Who cares? Like as long as you understand it. So like I am now trying to let go of this idea of like convincing people what I do is useful, because there is no, like, of course, I'm not going to like benefit humanity directly with my work. Maybe I will understand something. Maybe my work will be a stepstone for other people to understand something. So I think that is good enough. Like I don't want I've stopped trying to like tell people that okay, abstraction is really important and that is what leads to theory building and that's what leads to the progress of like human understanding of mathematics. Like you just have to like be local and do your thing, and what happens happens.
Yeah, exactly. So it is what happens is happen. Like you're not going to sit there and plan for a Nobel Prize, but if it happens, it
No,
happens.
yeah, of course, like not like let go of Nobel Prize. Like even with my PhD thesis, like what results are going to go in there, how useful it is going to be, whether it is something that I will pursue in my postdoctoral research, or whether it is going to be my field for the rest of my life.
Yeah.
Like if I start thinking about these questions, I'll feel immediately overwhelmed. And that's why, like, right now, what I'm working on is absolutely something I love. There are bits and parts of the proof that I have worked on which are just so stunning to me. So I think that's good enough.
What is
Like
stunning about them?
like so different things appeal to different people, right? And so I was trying. So there is this new thing called defects. Like we know how physicists have had defects for a long time. So imagine you have a perfect crystal, and there is like a place where something like the symmetry is broken. So there is a defect there. So there are different ways physicists work with defects. Defects are very interesting and they just tell you a lot. And then there are these things called topological defects, which can move around wherever they want, but they're so stable, like they will not disappear out of nowhere. So they
Okay.
will just exist, but they have some freedom to move around.
Oh,
So there
really?
are these things called topological defects.
Okay.
And so one of the things, like one of the people in my Oxford physics, like mathematics department, they are a physicist, and they had like this paper where they said like QFTs of D dimension have D minus one category of symmetries. And this statement was like, oh my God, I don't,
Hmm.
how does this make sense? And as physicists, they can go ahead, pick up examples and try to like do some things
Hmm.
with it, but just this statement had no proof, no, not even like any mathematical grounding. It
Are you
was just
talking about
like a
Emily?
not Emily, like
Okay.
there, but Emily does category theory,
Okay. Okay.
but she's a mathematician.
Okay. Okay.
But so the physicists are very good with like coming up with heuristics, which
Hmm.
they think are true, and then they will go find examples and find things to play with. Whereas what I am motivated by is turning that heuristic into a mathematical statement or a theorem. So I'm not really as driven to like find examples and like do computations, but I'm more interested in what context can I make this heuristic precise? In what context will this actually have the strength of being a theorem?
Hmm.
Uh, and I went to my supervisor. I was like, this doesn't like how, where, what? Like I was like, this doesn't
Hmm.
make sense. Like, how can this be true? Like, in what context is this true? Of course, in the examples that they were doing their computations in, it was true. And then my supervisor is like, okay, in we can try to like so there are so many things that are not defined, like d dimensional QFT
Hmm.
for a mathematician, like for a physicist, it is something that takes a d-dimensional like space-time manifold. So we live in four dimensions, like there is a d-dimensional manifold, and then they can do some quantum field theories on it.
So manifold is just an object, right? In the quantum field.
Manifold is like a space which locally is trivial. Like we said, like global and local, right? So
Hmm.
locally it just looks like flat. So a sphere, like a ball, is a manifold. So if you are a little ant, whenever you are on the sphere, you think everything is flat and everything is normal.
Okay.
Whereas the global geometry is different. So you can imagine like being on a torus, like on a
Hmm.
donut,
Hmm.
or being on a more complicated
Hmm.
geometry. So that for physicists, d-dimensional QFTs is not something they spend their time thinking of defining. They
Hmm.
just know quantum field theories that are whatever, four-dimensional, 10-dimensional, whatever. They just play with it. But for a mathematician, it doesn't make any sense. So I was like, okay, can we make this statement precise? And that started off one of our projects, just trying to make some statement precise in some mathematical way. And like the proof of this took more than 2 years, and not even like we didn't even get somewhere. We like started off wanting to do something, and even the first like preliminary step of it took 2 years to make something precise, which physicists are just happy to like go with.
Hmm.
Like they're just happy to like have this as a heuristic. But even to make like 0.1% of it precise took like 2 years of our time and like really intense mathematics. And the proof of this is something I like really enjoyed. And now
Hmm.
you'll be like, oh, what does it mean to enjoy a proof? Like, what do you mean by something is stunning? And it's just like an idea that is so appealing. You're like, oh my God, this structure is so beautiful. Like, it's the same as somebody who would look at art, or
Hmm.
somebody who would look
Yeah.
at the mountains standing. You're just like standing there and thinking like, oh my God, this is so pretty. And what is pretty? I think for me, it is like the structure of that, like how these things work,
Hmm.
like little bits and pieces. For somebody like a giant machine with like little gears can be extremely stunning, like how everything
For
plays
a
its role
watchmaker,
in it.
yeah.
Absolutely. And it's similarly like if you're like staring at a tree, you can look at every branch and how like little leaves are on it. And like what defines beauty for us is some internal like thing. maybe it is learned, maybe it is acquired, but I think like what I mean by a proof being stunning is actually like the internet is so nice that when I tell people about it, they're like, "Oh, this is really cool." And for me, like being able to tell another fellow mathematician who's interested in my field, like, "Oh, look, like this is how this works." And I think that for me is beauty. Like,
Wow. Okay. I'm just going to pretend, by the way, that I understood D-dimension manifolds and all of that. I'm just going to like just
no,
nod
you
my head.
understand manifolds. You have
Okay.
to understand manifolds by the end of this. But you can imagine being a little ant on a football. Like, we are
Yeah.
all little ants on Earth, right?
Yeah.
And we think everything is like, okay, when I mean flat, I don't mean like there are no mountains or
No, no,
plateaus.
I
What
get
I
it. I
mean,
understand.
yeah, yeah.
So I think I think a popular manifold would be the Möbius strip, which was in the Avengers.
Yes. Yes,
Yeah.
yes, yes,
See,
yes. Mobius
I
strip is
understand.
a not so Mobius strip is trivial locally. So when you are looking at every tiny piece of that strip, you will be like there is a little interval and a
Hmm.
little like it's like a column, right? A
Hmm.
little piece of strip.
Yeah.
But the global geometry is
Of
twisted.
course. So
So that's
when
my
so
favorite
these are
non-trivial.
conformal, right? So when you zoom out, you stretch out, and you look at it from a bird's eye view, you'll know the
So, yeah. So, yeah, that is what conformal, like in my PhD thesis,
hmm.
like conformal field theories are what physicists discovered, that they are quantum field theories which don't depend on the scale. So,
Right.
even if you are like go in with a magnifying glass, it will be the same, or you can zoom
Like
out as
on your
much
phone
as you want.
screen, you can just pinch out, and the angles will remain
Yeah,
the same.
yeah, yeah. It's
So
it's like scale invariant.
I basically know everything. I've just
Uh,
read up enough to pretend that
no, no,
comfortably
no.
act out. Okay. Anyway,
There,
so yeah, you're saying something.
no, I was just saying there is no pretending. Like very recently, I've started calling myself a little large language model. So
Hmm.
even if I'm trying to learn a new language or if I'm
Hmm.
in a seminar where I don't
Hmm.
understand things, I think of myself as like this little stupid machine learning algorithm
Just making
who like,
connections.
yeah, absolutely, like just trying to be like a predictor in
Yeah, yeah.
some way. So and slowly you will start understanding, and who knows what is the definition of
Makes sense.
understanding. So
I
right,
think
like,
again going back to Eugenia Cheng, I think she's described it wonderfully, saying that AI is also kind of like based on the category theory model of drawing connections between random
yeah,
things. So
things,
yeah.
yeah.
Okay.
Yeah.
So are we good on time? Do you have to get in?
I don't have anywhere to go, but I'm also trying to look how many minutes are we into it.
I have no clue. Actually, it's anyway. Okay, so we'll wrap it up. Another 10 minutes, I think. Is that okay?
Oh, yeah, yeah,
Okay.
absolutely.
Okay.
I
So
am absolutely enjoying this. This is like
okay,
the nicest conversation.
that's great. Okay. So now it's on me to ruin it. So anyway, so okay. So I have some miscellaneous category questions. Um, I'm just thinking where to go. Hmm,
Oh, are you going to ask me maths questions now?
I hope not. I mean, I hope nothing leads to. Uh, okay. I have so many things. I think it's just I have so many things to cover. There's so much ground to cover. But anyway, let me pick and choose. Are there merits to abandoning problems that are too difficult?
Yes. There, where in within my PhD, uh, so this is also one of the classic PhD like research examples that for months my supervisor thought something is true, and I sort of took it as God's word. Like my supervisor says it's true, it must be true.
Gospel truth, yeah.
Exactly. So, and then he wanted me to find something, like let's say find a number. So he wanted me to do some computation, and he was expecting the answer to be something very nice, like pi or pi by something, like some nice cool number. And for months he was like, yeah, you should do it. And I had other things to do. So, okay, then then he was like, okay, now, like, he wants me to do this thing. And then I found out, and I was like, okay, I will do it. And then I spent whatever X number of weeks trying, like, day and night to find this nice magic number. And it turned out to be 0. And, and, and I was like, oh my God. And then I went to him, and then I was like, this is 0. Like, he was expecting this to be a non-trivial thing,
Yeah.
and hidden, like, revealing magic.
Yeah.
And this was 0. And I was like, oh God. And and then like, he was like, I'm not convinced. And then I convinced him. And then we found some like 80s French paper, which was hinting towards the fact that this thing was going to be 0. So I was
0.
like, okay. And my computations say this is 0. He was like convinced. And then this like old French paper says that this is going to be 0. So I was like, okay. But now how do we like reconcile? And now it has been more than a year, and that problem is indeed too difficult for us to solve. So now we just live with the fact that this thing is not, this place was not where that factor was hiding. It's hiding somewhere.
else.
But yeah, so, and now if I had to spend like the rest of my PhD trying to find where this thing was, and still, like, there is no guarantee that we will find where this thing was. So then you sort of like put it on the side burner. Like, you don't abandon it, but you just let it be. So now next time I'm in a conference or something and I meet somebody in the field, I can tell them that, oh, we did this computation and this was 0, so we don't know where the central charge is. Like, and then they can have some thoughts about it, but I can't spend my PhD trying to do this. So that is, in that sense, I've sort of abandoned it. But emotionally, I've of course not abandoned it. So you sort of have to gauge for your next target for your PhD or for this paper, whether you want to include this thing or not. And
Because
it's very hard.
you're spending so much time on one thing.
Yeah. And you are also very attached to it. So,
Right.
like, every time you're writing a paper, you're like, but if I prove this other extra thing that will go in this, and that sort of like, you can't ever get enough. But then that's where, like, the supervisor says, no, this is too
Time
difficult.
to stop.
Yeah. Or that, like, we can, like, think about it, but let's, like, put it on the side. So, yes, there are times where you abandon things that are, in the moment, a bit too difficult.
And then there are times when things are not moving along great and you're stuck, and then how do you keep yourself motivated?
Just because you find these things beautiful. And
you have to remind yourself.
Remind yourself you absolutely love these things. Remind yourself that your worth in life is more than that. So even if I don't end up being a mathematician, I will not stop loving these things. And why is it so important for me to get this right now? So that I get a job in the future? Okay, let's get rid of that stress. Like, I'll do something else. I'll become a high school teacher. I'll do whatever XYZ thing that I am also passionate about. So that gets rid of the stress of wanting to get this right now. And then you're like, okay, but I love thinking about these things, so I'll think about them. And that is sort of like, that brings you back on track somehow. So for me, like, getting rid of measuring, like, things that measure progress help me like enjoy the process more and be better at it more. Of course, I can't.
You're not weighing yourself when you're working out.
Yeah, exactly. Okay. You're not weighing yourself. Like, okay, people tell you to like keep track of how much you have improved every week and so on. To some people, it gives motivation. To me, it does give motivation sometimes, but it can also like make me feel anxious. So then you can, for every individual, you can balance, find your like right balance. So of course, like, I would want to understand, like, for me, my yardstick would be that, so we have this thing called like confirmation of thesis, which is sort of like a pre-submission of thesis where somebody else gauges whether your thesis is on the right track, whether this has the potential of becoming a thesis in a few months or a year or something. So for me, if I like have enough material for my confirmation, then I think that is like a good enough measure. But every day I don't need to like sort of keep checking. Yeah, keep measuring.
Okay. Okay, so I'm sorry, there's a lot of questions here. I'll have to skip through. And final question. I give you a magic wand, and you can do just about anything you want. You can research, or you can go in any direction you'd like to go in mathematics or your field or physics or whatever. What is it? It's like I'll give you the keys to the best labs and the best places. What kind of problem would you like to solve immediately?
What kind of problem?
Or with what kind of research would you like to go to?
I think I would like, I just happen to be doing mathematics, but I'm also like extremely passionate about neuroscience. And it's a funny story that I actually came to Oxford wanting to do like research in neuroscience, like on neural networks.
Mm-hmm.
And somehow I decided that I will do so. I personally feel that the mathematical structures that I'm currently working with, they are so general and so powerful that they obviously describe quantum field theory things, but they also have potential of describing like neural networks. And there are some groups in Paris and other places which work on this, like doing like algebraic topology methods on neural networks. And if you were actually to give me like a magic key, I would want to like advance our understanding of human brain a lot.
Oh, wow.
And yeah, that is like my strongest like belief. Like, how are we doing mathematics? We are doing mathematics with our human brain, right? Because as a byproduct of evolution, as a byproduct of wanting to survive, we have developed this like prefrontal cortex, which is like has complexity enough to deal with these abstractions and deal with all this like amazing things we do with our brain. So for me, like that is like the epitome of like understanding ourselves, not necessarily like consciousness, but just like the complexity theoretic nature of our brains. And I believe that mathematical methods can be very powerful. Like at the end, when we described how a like a neuron, like a synapse works, it was like the Nobel Prize was given to it because we wrote a differential equation which told us how the synapse works. Like there is this potential difference, and then like there is a transfer of ions, and that's how the synapse works. So I think like understanding something is giving a mathematical description to it. And for me, like that would be like the ideal thing. Like if we are able to describe or even prove mathematically the like network structure or the complexity of human brain, like any center, like language center or decision making center. I think like right now we're just giving models for it. Like but I would want like a more pure kind of description. So that is like a dream.
Wow. But that's a very interesting and unlikely answer. But okay, thank you so much, Nivedita. I have adequately wasted a lot of your time. You could have done something very useful with your time, and you
it's
spent
a Saturday. You should at least encourage me to take a week.
That's also true. That's also true. Thank you so much, Nivedita. Thank you so much for doing this. What was your experience like? If you let me know, that will be great.
Oh, I think I absolutely loved like our conversation. Like it was the first time I had gotten a chance to talk about like hormonal things affecting your motivation to do things, creativity, productivity, and also like just how to like talk about being passionate about mathematics to an individual who might not feel that they are passionate about it, but just to like you're not but yeah, like I think I really enjoyed it, and it was also a very relaxing experience for me. So
great. Thank you so much, Nivedita. Thank you for doing this. If you learned something new from this episode of the Horsemouth podcast, do rate and review us on Spotify, Instagram, X, or wherever people engage with you the most.